So that's the third video of this chapter. We will be talking about source transformation and equivalent circuits. Similar transformation we have seen in time domain, so we will be repeating this transformation in frequency domain. Analysis by source transformation reduces independent Kirchhoff voltage law or Kirchhoff current law equations, good for analysis. So if you remember the source transformation, let's go inside. Any independent voltage source connected with a serial impedance can be replaced with an independent current source connected in parallel with the same impedance. So that means this 2 is equivalent to this 2, and other way around, this 2 is equivalent to this. So since we are changing the independent sources, it is called source transformation. So in the previous one, we used the concept of equivalency, but in this one, we replace the element not including the independent sources. In here, we are talking about equivalences, which includes the sources in it. That is why it is called source transformation equivalency. So how we are going to prove it? You're going to so when you replace this 2 with this 2, this unchanged element in here, which is load, voltage and current should be the same. So here is the calculation of this load, voltage and current on the left hand side, and this load and current on the right hand side. If you replace this independent current source with Vs over Zs, an independent voltage source is equal Vs Is. If you use these two, then left hand side load voltage and load current would be equal to load voltage and load current on the right hand side. So you can prove it your own. So you might say that what is the use of that? The use is this. If you look at the left hand side, we've got 3 nodes here, but if you look at the right hand side, we've got 2 nodes here. So that means you reduce node 1. That means you're going to reduce, you're going to write less number of Kirchhoff current law equation. So where you're going to use it, assume that you have a circuit in this form, and it has got many other elements in it. So you can replace any element in here in this side. So, and you made a decision that you solve that circuit by using the node voltage method. In the node voltage method, we will be writing Kirchhoff current law equations. So if you replace this 2 with this one, the number of equations that you're going to write is going to be less. That is the advantages of it. Another additional advantage, in here you're going to write one additional circuit supplementary equation. Why is that? Because for this node, the current of this element is going to be as unknown. But in here, you're going to write current law equation, so you know this current independent current source current. You don't need the definition. You can use the definition relation in this equation, so that helps. So that's the advantages. Other way around, if you decide to solve your circuit by using the mesh current method, and the circuit is in this form given to you. So if you do the source transformation, you can reduce the number of meshes. How? You've got 2 meshes here, but in here you've got only just 1 mesh. So you reduce the number of meshes That means you're going to reduce the number of Kirchhoff voltage law equations that you're going to write for the meshes. That's why it is important. Maybe we could understand a bit better if we examine the situation on a given circuit. So this circuit is the one that we use for the serial parallel connection equivalency. We will be analyzing this circuit by using the source transformation. So if so you can replace this time domain circuit, transfer it to the frequency domain circuit. Now what we see here, that's that green area here, so we transfer all these elements to their impedances. These are impedances of this element, and this independent source phasor, voltage phasor, is this written here. So those two replace with the independent current source by using the source transformation, it becomes this. In this case, those two resistors are connected in parallel, so those two blue ones are connected in parallel, so you could put just one element here. So this becomes an independent current source connected in parallel with a resistor, so you could use the source transformation. That transformation makes it this one, so you can use that pink one here to this pink one by using the source transformation, so our independent source here becomes independent voltage source here. So in this case, those two, inductor and the resistor, are connected in serial, so you replace these two with impedance. Also these three of them are connected in parallel, so you add those up, all these impedances, just one impedance, then you end up with this. So by using source transformation, we transfer this to this. What happens? What does this mean? This current, whatever we measure it here, is going to be the same as that 10 ohm resistor current. So if you do the calculation, you end up with this. So that means you found that current. Once you found this current, as we explained already, you can find all the elements current and voltage phasors, and you can always transfer these phasors to the time domain currents and voltages. So that is the equivalency concept that we could use in frequency domain. This concept is related with the source transformation. Source transformation included equivalent circuits that we have just seen. So let's see where we are now. So this video is about this frame. So next frame is going to the general analysis techniques. These are some useful tools which is available in the frequency domain. One of them we just explained that we cannot use it in time domain, but we could use it in frequency domain, and this is the tool that we use in time domain, both in time domain and the frequency domain. So that's the end of this video.